Hey everyone, and welcome to this next installment in the series about supercharging your Kubernetes deployments with Flux v2 and GitHub. And in this part 5 already, we'll look at Helm deployments. Now, how exactly did we end up here? Well, in the first installment, we looked at installing the CLI and bootstrapping a cluster. Then we took a small detour and looked at how customize works, because Flux v2 is using customize quite heavily. In the third video, we looked at creating Git sources and deploying our YAML manifests with customizations, but we kind of skipped the Helm charts deployments. And then in the fourth part, we looked at monitoring and alerting. Now, of course, we cannot go without looking at the Helm chart deployments as well. And that's what we'll do in this video. What do we have, or what are we going to create? Well, we're going to bootstrap our cluster from a new repository. I'm just going to call it the Helm infra repo. And I'm going to work against a kind cluster, so a local Kubernetes cluster on my machine. As you know from previous videos, when you do a bootstrap, you select a folder to contain all the components that you'd like to use. That folder will contain the Flux system folder. And of course, to the folder that you choose, in our case, that's an app cluster folder, you can add custom resources. Now, in this installment, we're going to take a look at creating sources, but instead of Git sources, we're going to create Helm sources. And we also look at creating Helm releases to deploy Helm charts to our cluster. Now, the sources we're going to use are the following ones. We're going to point to the bitnami Helm repository because we want to install a Redis using a Helm chart. Next, we're going to point to one of my own repositories. Yeah, it's called Reg from Remote Registry, right? And it contains the real-time chart for the app that I want to deploy, my own app, so to speak. Be aware that the sources you're going to create with Flux do only point at the repositories. They don't include information about the chart, but I noted the chart there in the diagram so that you know why we point at those repositories. How we refer to the chart, you'll see when we create the Helm releases. Of course, we still have the app we are deploying, and that is the sample real-time app written in Go with a GitHub action that builds and pushes container images when the real-time app sources change. Now, let's check first how we can deploy these Helm charts without Flux v2. To install the Redis chart on my cluster, I of course need to have a Helm installed on my local machine, and kubectl has to point to the cluster I want to work with. And in this case, that's kind. It's running already on my machine here. I first have to add the Helm repository that contains a Redis chart, and bitnami is a well-known one. So I'm just going to add this one here. Great, the Helm repo has been added. Now we will install the Redis chart. And we do that with the following command. We can use helm install Redis. And I'm going to set a couple of parameters. I'm overriding some of the values in the chart. For example, I don't want to have a full Redis cluster, and I also don't want to use a password in this case. This is just for my example app, which doesn't need anything more than that. Let's do so. And let's install the Helm chart. And it's done already, although it is not waiting to see if it's done. I didn't use --wait there. So normally what you would also be able to do is to add --wait here, and you will also check if indeed the installation is done properly. You will wait for the installation to finish. Didn't do that here. Let's take a look at what went on here. So get pods. What do we see? We see a Redis master 0, and we see that one running. And if we get the services, we see a Redis master service and another Redis headless service, but the Redis master service is the one that my app will need to use to connect to Redis as its backend. With the Redis backend deployed, I can now deploy my Helm chart for the real-time app. Of course, you have to have a Helm chart for that app first. You have to create that one. I'm in a folder now, the project's Helm real-time app folder that contains the chart that I need to use. Of course, I created this chart myself. In this video, we're not going to look at the details of how you create a Helm chart. Maybe I'll make another video about that, just for fun. But in this case, just know that this chart will deploy my real-time app production image. Let's take a look maybe in values.yaml, because that one, of course, contains a couple of my, let's say, the default settings I want to use. So as you can see there, the values YAML contains replica count of 3 for production. I have a variable as well, or a parameter called Redis host, which contains the Redis master service name and then the port for Redis to use. And as you can see here, I'm going to deploy to the default namespace, so I don't add a namespace behind Redis master. So there's no namespace here, right? Just for this example. Then the image I'm going to use is the Gebake Flux RT image, which my GitHub action is always creating. And I'm going to choose here to deploy the image with tag 1.0.2. So if I just deploy this Helm chart like this with the current values as they are, I would just do that with Helm install and then real-time app, because that's the name I want to give this Helm release. I'm going to use --wait in this case, just to wait until everything is deployed. And what is the Helm chart I want to actually install? The one in the current folder, right? So the dot for the current folder. Let's see if this works, and let's do the installation. We have to give it some time, because in this case, of course, he's also waiting for the resources to be created. The Helm command finished. Let's clear this and let's do a k-get pods. And as you can see there, we have 3 instances of the real-time app running. And we also have our Redis master running over there. When you run Helm ls now on your local machine, you will see that the 2 Helm chart have been deployed. You can also clearly see the version of the chart. So the chart version is over here. In this case, you can see Redis, the chart version is 12. The chart version of real-time app is 1.0.2. Now in this case, that corresponds with the app version. That's the version of my application. The tag I'm using for my image here doesn't, of course, have to be the case. And so the version of the chart can, of course, diverge from the version of the app. Now, I don't want to have these installed locally, of course, or manually. I want to install them with Flux v2. So we're going to just uninstall these charts, and we'll do that by using the release name. So I'm going to uninstall real-time app, and I'm also going to uninstall the Redis deployment, or the Redis Helm chart. So if we do Helm ls again, they should be gone. If we do k-get pods, they are gone as well. Great, now we are ready to bootstrap our cluster. And as I said, I'm going to use a repository called Helm Infra for that. That doesn't exist yet, so it will be created on GitHub for that. Okay, so the cluster is bootstrapped, and I already git cloned the Helm Infra repository to my local machine. As you can see in my, where I am right now, the path I'm in right now. And I also cd'd into the app cluster folder. And now we can create the source for the Helm repository, but instead of using Flux create source git, in this case, we're using Flux create source Helm. We give it a name, we call it bitnami. We give it the URL to the chart repository, which is this one here for bitnami, the interval of 1 minute, and we export this to a YAML file. When we cat out the Helm repo bitnami YAML, you see something like this. So it's a a resource of kind Helm repository, and of course the settings reflect what I use on the Flux command line. I synced up the changes to the repository over at GitHub and gave it some time to come into effect. And when you run flux get sources helm, you will see that indeed Flux was able to pull that source. The source is called bitnami and fetched the following revision. With the source created, we can now create the Helm release. So we use Flux create Helm release. We call the release Redis because we are going to deploy Redis. And of course, we need to reference the source. Where can we find this Helm chart? Well, that's of course in the bitnami Helm repository that we just defined. The chart in that repository is called Redis, and the release that I want to deploy, so the name I want to give it on my cluster, I want to use the name Redis as well. And of course, the Helm chart, it will be deployed, or we need to deploy the components somewhere. In this case, in this example in the video, I'm just going to deploy it to the default namespace. Let's take a look what's inside the YAML file. And that's indeed a resource of kind Helm release. Now, I do want to modify this Helm release a bit because, as you have seen previously, we want to deploy Redis and not use a cluster, and we also want to disable the use of a password. And we can do this with values. You see the values here to override the values in the chart basically, and here is where we set the parameters. I pushed the changes I made to the Helm release up to the Git repo on GitHub. And when you give it some time and you run flux get Helm releases, you see that Flux now has a Helm release, in this case, luckily, in a ready state. So ready is true and the release reconciliation succeeded. That also means that Flux was able to find the chart as well in the repo and was able to deploy this chart on your cluster. Let's take a look if that really worked. So let's do k-get pods, and there we see indeed we have Redis master now running. Be aware that if you now run something like Helm ls on your local system, you're not going to find anything because everything is done, of course, by Flux within your cluster. Okay, now it gets kind of more interesting because we have to package up our real-time app chart and push this to our own registry. In order to do so, we first set the following environment variable: Helm experimental OCI equals 1. That is required because now we're going to use Helm chart commands to save our Helm chart locally under different names. For example, you can do Helm chart save, and then of course a dot for the current chart, and then save it as real-time app, a colon, and then a semver, for instance, semantic versioning tag. Be aware that this saves the chart locally. Okay, that's done, but of course I would like to push my chart to a remote registry. Just like with Docker images, you would then also tag or save the image with a proper name. In this case, I'm going to save my chart as gebarech.azurecr.io/realtime app and then colon the semantic versioning tag. So very similar to how you would save a Docker image locally on your system. So I'm doing that now, and that saves the chart. Now it's time to log in to the remote registry. So I can use the following command for that, which is Helm registry login and then the name of the remote registry. Now I'm not going to do that because I am logged in already. What I am going to do is I'm going to push the chart to the remote repository. I'm going to use the following command to achieve this. Let's try that and see if that works. Great, that worked. He said he pushed it to remote one layer. Yeah, what you're actually pushing there is going to be an archive. I have an archive here in this folder. It will be similarly named in my remote repository. Let's check out that repository. Here we are in the Azure Container Registry, which I can also use to store Helm charts. The Helm chart appears in the list of repositories next to other repositories which I'm using, for example, for containers. If I click on Real-Time App, you'll indeed see the tag that we just pushed, 1.0.2. And you can also see that in the config, the media type refers to Helm over here. And the layer actually contains an archive, as I discussed earlier. Now we just have to tell Flux v2 how to get to it. Our Azure Container Registry is protected by usernames and passwords. It's not something which is publicly available. So we'll need to tell Flux later how to authenticate to it. One way of doing that is just creating a secret on your Kubernetes cluster in the Flux system namespace. I create a secret here which is called ACR, and then using the from literal option, I'm setting username equals to the name of my registry, the short name, just gebareg. And then the password is the one that your Azure Container Registry is listing. Now, where do we get that password? The password can be found on your container registry if you go to Settings, Access Keys, and you turn on the admin user. Now note, this is one way of giving access to Azure Container Registry. There are other preferred ways as well, but in this case, this quickly is something that works everywhere. So you enable the admin user, the username, as we've seen in our secret, will be the short name of our registry, and then you can use either of these two passwords. Now that we have the secret with our username and password to the repository, we can create a second Helm source. In this case, this Helm source refers to my Azure Container Registry, but do note that you have to add /helm/v1/repo over there. The interval set to 1 minute, and of course you can see that we refer to the secret that we called ACR that contains the username and password to authenticate to our Azure Container Registry. Let's just create this. Now that the source is created, I'm going to create the Helm Release for Real-Time App. Very similar to the earlier Helm Release, but of course now we refer to the other registry, the one we created over here, the Real-Time App one. The chart is called Real-Time App. You've seen that with the Helm chart push command. The release name is Real-Time App. The target namespace is the same as where we deployed Redis, which is default in this case. I'm just gonna run this command and this saves the file to my local Git repo. I also opened the file I just created with Nano, and I added a couple of overrides for the values of the YAML chart. For example, here I just set Redis host as the name of the Redis service dot namespace and then the Redis port. That's just an example. I don't want 3, but I want 2 pods to be deployed. And just to be sure, I set the service to type cluster IP. I pushed all the changes to the GitHub repo, and after a while, I can see that indeed there's a new Helm release for Real-Time App. And luckily again, the state is ready equals true, and the release reconciliation succeeded. That must mean that our application, the Real-Time App, was deployed. Let's check this out. Let's clear this and let's do a get pods. And what we see is that we have 2 replicas because I override the values YAML basically and set the replicas to 2. The default was 3, if you remember from the beginning, and they're both running, so that must mean that they're connected correctly to the Redis master 0. We can still make an improvement to the Real-Time App Helm release. Because Real-Time App depends on Redis to be available for it to start correctly, we can add a DependsOn line to the YAML file. And in this case, you see that we depend on another Helm release, which is called Redis. This concludes our look at Flux v2 and Helm. We created 2 Helm sources that point to Helm repositories. an open one, bitnami, and our own one, which is based on Azure Container Registry. And then from both Helm repositories, we installed a chart using the concept of Helm releases in Flux v2. So we deployed the Redis chart, and then we deployed our real-time app. And remember, we actually created our own chart for that, and we packaged up the chart and saved it into Azure Container Registry before we created the Helm release. I hope you enjoyed this, and see you in another video soon. Take care.